So in the last lesson, we graphed the sine function, and what we're going to focus on here in this lesson is how to graph the cosine function. And we're asked to graph it over that same interval from 0 to 2 pi. This time when we do it, we're just going to plot the quadrantal angles. We're not going to do the pi over 6, pi over 4, pi over 3 in each quadrant because we recognize that the quadrantal angles are the ones where we're going to see something interesting happen, whether it's a root or if it's a maximum or a minimum. So we'll just plot those here. All right, so 2 pi is the end of our interval. Pi would be right in the middle. Then we'd have half of pi, or pi over 2. And then over here, this would be 3 pi over 2. Those are our quadrantal angles within one full rotation of the unit circle. And then, of course, like sine, cosine is going to be bound between 1 and -1, because if we think about the unit circle, cosine is measuring our x-coordinates. Our x-coordinates will never go less than -1, and they'll never go greater than +1. So all of our points are bound within this -1 to 1. So we're going to see another cycle here, just like with our sine curve. But one of the big differences is going to be where this thing starts. Because when we start at 0, cosine of 0 isn't 0. Cosine, or sine of 0 was 0, but cosine of 0, that point right here, is the point 1, 0, and cosine is our x-coordinate. So cosine of 0 is 1. So this cosine curve starts at 1. And then as we travel to pi over 2, well, cosine of pi over 2 is going to be 0 because your x-coordinate at pi over 2 is 0. And then we can check pi. This is the point -1, 0, so cosine of pi is -1. And this is where it's going to bounce back because cosine of 3 pi over 2, if we travel around here, that's the point 0, -1. That's 0. And then finally 2 pi, cosine of 2 pi is 1 again. It's right back to where we started. So we can go ahead and fill in this curve. All right, now we know that there are all of these points along the x-axis where we've got radical 3 over 2, radical 2 over 2, 1/2. Those exist in each quadrant, but we're getting past the point where we're going to plot each of those inside of each quadrant because we know the behavior of these functions. So one thing to point out here about this function is that it looks a lot like a sine function. It's just that its starting point is at its maximum, whereas with a sine function, the starting point was at 0. So we're going to answer a few questions about the behaviors of sine and cosine here. And to help us, I'm just going to sketch the two functions off to the left, but you've got them sketched on the previous 2 pages of your notes. So for reference, we've got these off to the side. And now we'll be able to answer the questions. Each of these is going to refer to sine and cosine. So the question here for number 8 is, what are the domain and the range for sine of theta and cosine of theta? So we'll make a little sine of theta column and a little cosine of theta column. We'll carry this throughout. So domain and range. Our domain for both functions is all real numbers. Because even though these functions exist on this graph that we've made between 0 and 2 pi, we know that this continues in both cases, in both directions. And there's no limit to how many times we can travel around the unit circle. We can just go around and around and around and around. So we could keep graphing this thing through 1 billion pi if we need to, and even beyond that. The range is a little bit different because no matter how far we travel, this sine function is stuck between -1 and 1. So the range is stuck between -1 and 1. It's bound between -1 and 1. And by the way, I'm using square brackets here because it does actually hit 1, and it does actually hit -1. So I'm including those values. And the same is true for cosine. So they have the same domain and the same range because cosine also hits 1 and it hits -1. Are these 1-to-1? Well, usually when we talk about 1-to-1, that follows a discussion about whether or not they're functions, right? So are they functions? Yes, they're functions because they pass the vertical line test. Each input has one distinct output. But are they 1-to-1? In other words, are their inverses also functions? And the answer to that is no, because I can prove that each of these fails the horizontal line test. Right there, sine fails. I could pick cosine and it fails here and here. So not 1-to-1. And let's make a note. Fails the horizontal line test. Both of them do. When are sine and cosine positive and when are they negative? And we're talking specifically about the domain from 0 to 2 pi. All right, so let's figure out when these are positive. Our sine function. I'm just going to trace it. So right now, our sine function is positive until here. So that was positive from 0 to pi. Now I'm going to use soft brackets here because at 0, it's not positive, it's 0. And at pi, it's also 0. So I can't say that it's positive at 0 and pi, but between 0 and pi, it definitely is. And what about our cosine function? Well, cosine starts off very positive, so I'll be able to say between 0 and pi over 2, but then it's negative until 3 pi over 2. So for cosine, I would say cosine is positive from 0 to pi over 2, and then from 3 pi over 2 to 2 pi. And with those, actually, I could use square brackets because it is positive at 0 and it is positive at 2 pi. But I can't use square brackets next to the pi over 2 or the 3 pi over 2. All right, what about negative? Well, my sine function is negative after pi. So from pi to 2 pi, sine is negative. And from pi over 2 to 3 pi over 2, cosine is negative. So those are some pretty straightforward intervals. From pi to 2 pi, not including either of those values because sine is 0 at pi and 2 pi. And for cosine, it would be from pi over 2 to 3 pi over 2, also not including those values because cosine is 0 at those. And then finally, how long does it take each function to complete one full cycle? And this is what we're going to get into in our next lesson. Each of these completes a full cycle between 0 and 2 pi. Because remember, once we travel 2 pi radians around our unit circle, we're right back where we started. So whether we're plotting the position of the x-coordinates or the position of the y-coordinates, we're going to end up exactly where we started once we do one full rotation. So 2 pi. And that goes for both. All right. And what I'd like you to do is graph the cosine function on the practice. So right here, the day 2 practice, do this on your own just to make sure that you know how to graph that cosine function just like how we graphed that sine function before tomorrow.